Hi, welcome to another edition of Antique Radio Archaeology. Today we're going to begin the restoration of a Chelsea Model 107 regenerative receiver. Now this particular receiver has a very interesting background, and I'm going to get into that here in a minute. But this restoration is going to be particularly interesting in that I don't have a complete radio to work from. This is the only surviving example of this radio that I know of. I'm not saying there aren't more. I'm just saying that I've reached out to the radio community on numerous occasions over the last couple of years, and I cannot find another surviving example of it. As such, I'm kind of on my own here, and this thing is missing some parts and pieces, and I'm going to have to speculate on how this thing actually works. And there's going to be some interesting sleuthing going on here as we work through this, because I'm going to have to obviously draw this thing out and try to figure out what's missing and how it was meant to operate. Now I do have some interesting clues to work from, and that goes into the actual history of this radio. If you go back into the advertisements of the time, back in April of 1924, the Boston Globe had an advertisement for this radio. That advertisement was introducing a regenerative receiver with 4 tubes. This is the only known Chelsea radio that I'm aware of that has 4 tubes in it. So about a month after that advertisement came out, there was another advertisement from the Shepherd stores, also in the Boston Globe, and they were announcing that they had bought an entire inventory of closeout radios. Now these closeout radios were more than likely prototypes, and those radios were actually a receiver and a separate amplifier. The receiver had 2 tubes, the amplifier had 2 tubes. There was a total of 4 tubes between them. So that leads me to believe, and because of the advertisement which states it, that the Model 107 was the replacement for that pair. Now, this is where it gets interesting. Of that pair, I only know of one surviving example of the amplifier. The radio itself, I've never been able to find a surviving example of. Now, there is a rough illustration in the advertisement, but you know, it's not clear enough to really make out how it might have actually looked. However, the amplifier was clear enough that the surviving example is a perfect match for it. So there is actually another version of this particular radio, which is the Chelsea Model 108. Now that is more of a squared off faceplate, and it's mounted into a phonograph cabinet. And it was sold to manufacturers that were producing phonographs with radio. There is an interesting Gimbel's version of this radio, and that is also mounted in a cabinet with a speaker. However, they did not use the 108, they used the Model 107 because the faceplate matches on it. So those were also sold to Gimbel's as the ZR2. Alright, so here's what we're dealing with. The case on this thing is in incredible shape. I don't really think I have to do much, if anything, to that. I'll probably do a good cleanup on it. There is a plate that goes here. Somebody just stuck a brass plate on there for some reason. The correct one would have the regenerative receiver information on it. I'll have to have one of those made up at some point in the future. The rest of this needs to come out. Let me go ahead and real quick. I've got some wires here. some hardware. And I've got this right here. This is a nice little clue that I'll get into here in a minute. So let's go ahead and set this off to the side and take a look at what we've got. So obviously the faceplate's in pretty decent shape. It could definitely be cleaned up, and I could renew those the lettering on all this. Luckily on my knobs I've got the 2 vernier knobs, which those are kind of hard to come by. Both of them go with capacitors. This here is my regenerative knob. This allows the regeneration. This is one of my filament voltages for the detector, and this is the filament for the amplifier. Now the problem is the amplifier filament knob is not correct. We do have an on-off switch for the long and short range antenna. This is just the on-off switch for the power to the filaments, and then I have a headphone jack here on the front. What we've got here, got some kind of brackets that appear to be original, and it's just got some felt there that is gluing it to the tube bases. We have our capacitors here. We have one of our coils. Here's the other coil for regeneration. Those look to be in pretty good shape, although that one is broke off. Okay, so that's going to need to be repaired. Here's where things are getting weird. Somebody replaced that rheostat. Chelsea rheostats are next to impossible to come by, and that really sucks. I wish I had the original rheostat because I could always rewind it, but I don't, so I'm going to have to find a replacement somehow. The other thing is, because of that, they did some rewiring, and I've got some wires that are just loose, and unfortunately there is nothing to hook up my power, my speakers. All that stuff is not here. I'm missing a grid leak resistor here. I don't know the condition of the transformers yet, but this here provided a little bit of evidence. This goes to that jack right there and comes up like this. These here are typically used on a terminal block, and if you look at the terminal block on the model 104, you'll see what I'm talking about. A little bit of additional evidence is I've got a nut and a screw and a nut and a screw here that aren't attached to anything. That would hold an L bracket, just like the 104, for a terminal block. Now I know I need a terminal block to accommodate for the power, the speaker, antenna, etc. Let's take a look at those transformers real quick. Alright, now these are typical Chelsea Model 50 transformers, so I already know the primary should be around 1K. It's 954 ohms. Secondary needs to be about 5K, which it is, so this one is definitely good. My primary here, that's not good. I got 6K. I'm definitely in need of a transformer coil on that, so that transformer is going to have to be repaired. One of the things that I'm probably going to have to do first is get that drawing finalized, and we'll correct it with what we think is going to be there. Now I'm going to definitely have to model that terminal block after the Model 104 and make some changes to it. One of the things that I do know about Chelsea radios, every single Chelsea radio that has these holes has the exact number of connections inside to the number of holes. Now this one has 3, 6, 9. So I know I have 9 connections inside on that terminal block. I believe the 104 only has 7 or 8, so we'll have to look at that and come up with a configuration. There's a lot of work that's been done. I went and got this wiring figured out. It took me a while, but what I did was I took this drawing that I did, and this is pretty much the way I found it, and I kind of looked at what I had going on here, and I came up with a component layout that should show you how this thing is supposed to have been wired. And I think it's pretty doggone accurate. And from that I was able to also produce a schematic for the radio. So now I've got a schematic which I've double checked, and from what I can tell this is definitely going to work in this configuration. One of the things that I had to do was come up with a little terminal board. This is how it's going to look from the top and bottom. I'm going to need a little piece of hard rubber or Bakelite in order to create that board, and that shouldn't be too hard. And I also came up with a little bit of a restoration checklist. Basically what I needed to do was figure out the wiring, which is done, draw up a schematic diagram, which is done, come up with terminal board layout, which I just did, construct the terminal board, come up with a rheostat knob to replace the one that's missing, repair the transformer that's bad, clean up the parts that are remaining, restore the faceplate, clean that up a bit basically, clean up the cabinet, and reassemble everything and test. So that should get this thing back to operational. I'd say we got a lot to go, just need to jump into it and get started. So I spent a couple hours going through all my rheostats and came up with some sort of plan here. The problem that I have with Chelsea rheostats, and it's a big issue with every Chelsea radio, there's only about 8 radios that have these, and of those 8 radios I pretty much have all of them, and this one needs 2 of these rheostats. Now the issue that I have is right here. If you're measuring the distance between the attachment screws, what you will find is it's 1.25 inches, which matches these holes here on the faceplate. Most rheostats are about 1 inch, and in some cases 1 1/8 inches. I'd say 98.9% of all rheostats have those measurements. Very few have this Chelsea measurement. So that is one issue. The other issue, for some reason, Chelsea decided, instead of using the standard shaft coming out of the knob, I was able to find a Chelsea knob off another radio. I do have the knob, I do not have the rheostat. But as you notice, the knob has a threaded end on it. Most rheostats are this type of knob configuration. So I don't have a shaft. So if I use another rheostat, which is what I want to do, I'm going to have to come up with a way of creating a shaft for this. Now, this particular rheostat has the right measurements as far as resistance value. It's 25 ohms. It needs to be 25 to 30 ohms. The other kind of requirement I was looking at was making sure that I had a hard rubber one so that I can re-drill these holes. If I use Bakelite, that's a little bit harder to drill and less likely to have a successful outcome. And one of the issues that I also have is, like in this rheostat here, if I were to use this one, the problem is to bring those, space those out to 1.25 inches, what's going to happen is it's going to put the nuts on the resistive material. So that makes that impossible to use, so I can't use this rheostat. This one has a little bit more room to work with, so I can make that happen. Now the problem is, again, the shaft. What I think I'm going to do here is I'm going to take this here and I'm going to solder that on there. And then I'm going to go ahead and solder it onto that shaft. And I can go ahead and make this shaft the correct length when I'm done. And that should allow me to use this rheostat with this knob. So that's the plan. Alright, so after a little bit of cleanup, that's pretty much what it looks like. Okay. What I came up with is, I do know the board itself is 1.5 inches wide. So I cut 1.5 inch strip here. Now, the length is going to be based on the fact that I can't go past this and I can't go past this, otherwise I'll run into it, because that's about where the board's going to lay. So with that in mind, if I measure from here to here, I'm at about a 5.25 inches in width. That is the longest my board can be. So that's where it needs to be. And I know it needs to be out a little bit, and I'll show you here in a minute why. This here, I know, is my B++ output. And it ties to this, and I can tell by the solder pad that came off the jack how this thing was originally soldered in. And it's like this, which means this thing is like that. So at that weird angle, that puts that right about there. I use this to space this out. There's 5 there. 4 there. Okay. Now, I've got a little bit of a problem. When I did my layout, I anticipated this being straight across. Instead, it's going to be like that. I'm going to have 4 at the top and 5 at the bottom, because the lettering has to go this way as if you're looking into the radio. That's how it is on the other radios. So really what I need to do is move all these up here and all those down there. Okay, there it is. I took a little scribe here and I went and punched little holes, which you can see here on the plate itself. Now if you look right here, I've got a bracket. This little L bracket here, what I did was I took, this is a curtain hanger bracket, and I went ahead and cut off the little end here and created one of these. And then what I did was basically bend it over, and now I have a little L bracket. So let's go ahead and alright, so got the bracket there. Now this is going to sit right here on top of that bracket. Now one of the things, and Chelsea did this on another radio where they had the bracket actually tied to the A minus, and I'm figuring that's probably what they did here, do the spacing. So I'm going to do that. I'm going to go ahead and take my A minus, and this is where my terminal will be. A minus. What that's going to allow me to do now, mark the hole. I went downstairs and drilled the hole, so what I'm going to do now is countersink the hole so that I can use the right hardware here. So there it fits. And alright, there you have it. Okay, so we're at a point now where I can start disassembly. I've gone ahead and replaced that rheostat. I made up a terminal board, and the other couple of things that I needed to do was to repair this coil here, which I can't do while it's in place. I need to take that apart, and same with the transformer. However, on the transformer I'm going to just replace the entire thing. I do have some replacements. The reason why I'm going to do that is because I do have a video on how to replace that core, and I'm also going to be producing a new video on how to replace those cores with one of these, the P-T431 that you can get from Antique Electrical Supply. So keep a lookout for that when it comes up. But in the meantime, let's go ahead and get this thing disassembled. I do have plenty of pictures taken of this. I also have my layout drawing that I went ahead and did in advance. So we're at a point now where we can just start disassembling. All right. Okay, I'm going to repair this coil here. Alright, so that's repaired. That should hold the wire in place. Okay, so I'm going to begin front panel reassembly. Start off by putting the brace back on here. This is for the upper part. Alright, I'm going to go ahead and try and get this thing back in here. I know it goes from here over to here. It's going to hit these two transformers. My issue is when they put the other rheostat in there, they bent this all to heck to accommodate it. I think this was bent straight down. So I want to remove this tab and try to rebend it back to the way it was, and then see if I can work with that. So let's do that first. Oh, this goes here. Alright, so alright. So one of the things I'm wanting to do is I want to get my A minus to this bus wire. This is my A minus here, and it's actually going to use this bracket and tie the ground and the A minus together, and it's going to screw into that bracket. So if I solder this bus to that bracket, I will get that connection. So I'm going to go ahead and do that. This one goes over here to the filament. There. Okay. Here we go. Okay. So I picked some of these up. These are what's called dry transfer letters. And what I'm going to be able to do is I can rub these letters onto here and label all my terminals. But what I need to do in order to make them permanent is I'm going to have to hit it with a coat of clear lacquer. So I'm going to go ahead and clean this up a little bit and get the dry transfer letters on there. Okay. Just need to put everything back. Alright, on the cabinet I have no desire to do anything fancy. I'm going to hit it with some restore finish after I put some new feet on it. So I did a little bit of pre-testing, and what I discovered was the only way I could receive any station, which the only station I was able to receive was the home radio station, which is the most powerful signal that I have. And the only way I was able to get that is I had to basically go max clockwise on my dials, and it sounded horrible. So I had to do, and I wasn't getting any regenerative squeals or anything. So this thing was really frustrating me. I did quite a bit on it. I tried swapping out the grid leak. I tried different tubes, all kinds of different things. And what I wound up having to do, I had to replace the coils here on the tuner. Now, in order to replace those coils, what I did was I used a Chelsea Super 5 coil, which I had some spares, and that wasn't too hard to do because it looks identical to the original coil. And as you can see, they're exact same size. So the only difference between the Super 5 coil and the 107 coil is, as you can see, I have one coil here that goes between the plate of V1 and comes all the way over and hits the filament side of first transformer, which supplies the 45 volts to the regenerative circuit. And then the other side of the coil goes between the grid leak and it comes down here through this resistor to ground for the grid circuit. So the problem I have is that center tap right there, because this allows you to select between a couple different bands. Now, without the center tap, I had to make one. So in order to do that, what I did was I took the insulation, kind of scraped it off here, and soldered a wire on to the center there, figured out which coil it was, and then hooked it all up, and that seems to be working. And I'll go ahead and fire it up here just real quick. So the one thing I really don't care for on this Chelsea 107 is how it mounts in its case. Now these two bars here need to go inside of the case before I can attach it to the plate. They have to come off because it will not slide through the grooves that were designed for the faceplate with them in place. And it's just really kind of kludgy. And then once I get it in there, I put these things on top of them and then screw this down, and this clamps between the bottom of the case and this board. So, but it just makes it hard to pull out and put back in if you have to do it several times. Okay. Let's go ahead and get some tubes in there. Okay, so let's start hooking up everything. Let me get my speaker jacks here. Go here on my output. And then I got my antenna. That's my ground connection for my antenna. And I will hook a ground to the antenna terminal itself, so that'll take care of that. And that's also my A-, by the way. Okay. Now, I'll go ahead and hook up my A plus. A minus. My B minus. My B plus 45. And this is my B plus 90 volts. Those are all my connections. Alright, so let's give this thing a go.
Which brings us to that new one by John Mercer. A good song, and we'll buy it for Steve Taylor and
Let's go ahead and try the headphones.
Here goes the nickel and...
Sound great. Alright, so let's see if we can get another station.
Not very difficult. Really, really stupid people do it every day. Whenever I think about it, I think I'm not doing nearly enough. You're doing too much.
Okay, so as you can see, I can definitely pick up another radio station, so I'm going to call this one complete. If there's anything I've ever learned about restorations, that is to always expect the unexpected. On this particular one, I was really shocked to find after all the work that I had done that it didn't work. And I spent a long time troubleshooting it. I actually did another video on another restoration in the time it took me to figure out what was wrong with this one. And as it turns out, what had happened was after I restored the radio, I discovered that it just wasn't tuning in a station. But if I happened to put my finger on the selector capacitor, I could get a signal for my home radio station. And that didn't make a lot of sense, but it also proved that everything beyond the RF section was working because I was able to hear it loud and clear. So that limited me to just a few components there in the RF section, and none of it made sense because the coils all had good continuity, everything else seemed to be in perfect working order, and I finally decided to just go out on a limb, and I replaced the RF coils with the one out of the Chelsea Super 5, and lo and behold, that was it. And it makes no sense. I don't get what happened, but I'll accept it for what it is. And we now have a working model 107. I hope you enjoyed today's video. Happy restorations, everybody. Hope to see you again next video.